Hey, this is Avi Gutman with another Ask Me Anything event brought to you by quantreasoning.com. I invite you to join me live next time. We do this every Saturday at 11 a.m. Eastern, and you can attend for free by starting your free trial at quantreasoning.com. Can you let me know in the chat box which statement you would start with for this question? Yes, so I think the most important things that you said there, Himanshu, there were two things that I want to pick out from there because they were great. Number one is that what this question is really asking, this is a yes-no question, right? And it's asking, is the product of x and y negative? When we ask ourselves, under what circumstances would the product of x and y be negative? And the answer is, that would happen if they are on opposite sides of zero. So we can and should rephrase the question to our x and y on opposite sides of zero. So that was good. Once we've done that, we have to ask ourselves, looking at the statements, which statement would we like to start with? And I always say start with the statement that is easier to evaluate. Often one of the statements will be obviously sufficient or obviously insufficient, and if that happens, you want to start with that one. In this case, that would be statement 2. As you said, all statement 2 tells us is the relative order of x and y, so we could say x sits to the right of y on the number line. But then when we look back to what our question was asking, we would be forced to ask, but where is 0? Is 0 in between them? If so, that's a yes. If 0 is not in between them, that would be a no to the question. So statement 2 is what I would consider to be obviously insufficient to answer the question, and then we should eliminate the answer choices that claim that it is. So I think that is the correct way to start thinking through this question, is start by eliminating B and D, because that part is relatively easy. And I say relatively because evaluating statement 1 is going to be quite difficult. Now, when it comes to evaluating statement 1, it sounded, Himanshu, like you were relying maybe on some memorized properties. And I think that you might have also misapplied the property that you memorized, because if I understood you correctly, I think that you missed something. But I want to give you all a bit of general advice here for a moment, forgetting about this question in particular. I want to tell you what my son is doing right now. My son is 6.5, and he's upstairs creating a 12 by 12 times table from scratch. And I'm having him do that over and over and over again until eventually he knows the times table. But he's not memorizing it. I don't want him to memorize it, because when you memorize that, for example, 6 times 7 is 42, you're missing out on the opportunity to infer that 6 times 7 is 42. And how would you infer it? Well, for example, if you know that 6 times 5 is 30, and you know that 6 times 2 is 12, then for 6 times 7, you add those two, and what happens when you do that is you're improving your algebra, even though you don't know the word algebra yet, because you're only 6.5, but when he gets to algebra, it will be just obvious, right? Because in algebra, he'll see, oh, if you have A parentheses B plus C, and it turns out that that's AB plus AC, and all his friends in class, when he's 12, they're going to memorize this rule, this property, called the distributive property. But he's not going to memorize it. He'll say, well, of course that's true. I mean, that's how I've been doing 6 times 7. I've been doing it as 6 times 5 plus 2. And I know the first is 30, and I know the second is 12. So, of course that's going to be right. And that's the advice that I give people, not just for the times table, but for everything in math. And so I'm not a fan of reading some proof somewhere for this kind of inequality and then trying to commit to memory what that means, but rather infer it on your own every time you encounter it until eventually that inference is automatic. And that will actually improve your quantitative reasoning and your number line reasoning. Of course, I'm not suggesting that when you go to the test center, you try for the first time to make an inference from this inequality. Just as I'm not suggesting that when my son goes and takes the GMAT in a few years, he'll have to figure out that 6 times 7 is 42 by doing that. I mean, by then he'll just know that 6 times 7 is 42. The question is, how will he get to that knowledge? Will he get to that knowledge from memorizing flashcards? Or will he get to that knowledge just because of experience, just because he made that inference so many times that he just knows it? Okay? So that's what I'm suggesting here. So let's talk about this inequality here in statement 1. What observations would I make when I look at this inequality? So I think the first and most important observation when it comes to absolute values is to identify that the left-hand side is not negative. Why is it not negative? Well, because it represents a distance. A distance between two things on the number line is never negative. Right? This represents the distance between x and y. And by the way, I don't know who's to the left and who's to the right on the number line. I don't know the relative order of x and y, but this left-hand side represents the distance between them. And if I just draw a picture to show you that, right, here's a number line, and let's just say that one of these tick marks is x and the other is y, and I don't know which is which, so I'll just put an x here, a y here, and I put a double-sided arrow between them to illustrate that I don't know which one is which. They could be the opposite order, but what I do know, or what the left-hand side of statement 1 is describing, is this distance. So the left-hand side could be 0, right? But it's definitely not negative, because it's describing a distance. And that's the observation, the first observation that is important to make there, is that the left-hand side of this inequality is not negative. 0 could be anywhere. In other words, the left-hand side of statement 1 is not interested in the positioning of 0, nor does it imply anything about the positioning of 0. It's just talking about the distance between x and y. How far apart are x and y on the number line? That's what it's talking about. Now, when we look at the right-hand side, we also have to make an observation. And the observation that I would make there is that this quantity can be negative. Why is it possible that this quantity is negative? Because we're subtracting some unknown quantity from some other unknown quantity. And while it's true that neither of those quantities can be negative, so let me use a few more colors here. The orange quantity is not negative, the blue quantity is not negative, but when you subtract one from the other, it would be negative if what? If the blue quantity is greater than the orange quantity. So the right-hand side of this inequality can be negative. All right. Now, this inequality is telling us what? It's telling us that the left-hand side is greater than the right-hand side. So having made the two observations that we just made, we should say the following. We should say, look, if the right-hand side is negative, which hopefully you agree is possible, it's a possibility that the right-hand side is negative. If that's the case, then what? This inequality is always true. It's automatically true. Why? Because the left-hand side is definitely not negative. Remember, that was our first observation. The left-hand side is definitely not negative. So any scenario where the right-hand side is negative, this whole thing is automatically true because you have something that's not negative is greater than something that is negative, and that's always true. Do you agree? If we have something that's not negative, it's automatically going to be true that that thing is greater than something that is negative. Under what circumstances would the right-hand side of this inequality be negative? The right-hand side of this inequality will be negative in what situations? If the magnitude of y, meaning how far away y is from 0, that's what we mean by magnitude, if the magnitude of y is greater than the magnitude of x. So how would I say that in simple English? This is going to happen if y is farther away from 0 than x is. So now, what can we say? We can say, look, if y is farther away from 0 than x is, then statement 1 is saying something that is, of course, true. It's obvious. Of course, statement 1 is true if y is farther away from 0 than x is. And then you can ask yourself, well, okay, let's just look at that case. I mean, there may be another case to think about, but let's just pause here for a moment. If you know that y is farther away from 0 than x is, can you answer this question of whether or not x and y are on opposite sides of 0? No. So it's still possible that 0 is in between them. So if 0 is in between x and y, it's possible that y is farther away from 0 than x is. I'll draw it in a moment, but let's just think about it for now. And if 0 is not in between x and y, meaning x and y are both on the same side of 0, it's still possible that y is farther away from 0 than x is. I mean, why not? Why wouldn't that be possible? So now I can say definitively that statement 1 is not sufficient on its own, because statement 1 allows for any circumstance in which y is farther away from 0 than x is. And that could happen regardless of the positioning of 0 relative to x and y. So let's draw the two pictures that prove that statement 1 is insufficient. So one scenario is where you have, let's put y all the way out here. And as long as I put x closer to 0 than y is, and on the other side of 0, so something like that maybe, and we'll say, look, here's 0, here's x. And by the way, I wouldn't actually draw this on the test. I would just be visualizing it in my head. But even if you were to draw it on the test, it doesn't take that long to draw it. This is a scenario that statement 1 allows for. Does everybody agree? Because statement 1 allows for any scenario in which y is farther away from 0 than x is. So this is a scenario that statement 1 allows for. And the answer that this scenario would lead to is yes. This is a yes scenario. Why is it a yes scenario? Because the question wanted to know, are x and y on opposite sides of 0? And in this case, yes, they are. Okay. Now, an opposing case that statement 1 allows for, that would lead to a no, is where I put y and x on the same side of 0, but still have y farther away from 0 than x is. So I can draw a very similar picture and just switch the order of x and 0, and we're done. This is a no. This would answer the question with a definitive no. And this scenario is also allowed by statement 1. Why? Because y is farther away from 0 than x is. So I've now proved that statement 1 is not sufficient on its own. And we haven't even considered other scenarios that statement 1 can allow for. I mean, saying that y is farther away from 0 than x is would certainly fit the bill, but there are also other cases where y is not farther away from 0 than x is, and it would still be allowed by statement 1. But I don't even need to go there. Thanks to my two observations early on, just to remind you what those observations were, the left-hand side is never negative, and the right-hand side can be negative. Those were the two observations. And then we made an inference that any scenario where the right-hand side is negative would be allowed by the statement, because something that's not negative is always greater than something that is negative. And then we made the inference that this would be negative in the situations in which y is farther away from 0 than x is. And then we said, well, could you have scenarios in which y is farther away from 0 than x is that would lead to different answers to the question? And the answer was yes. It's pretty easy to come up with such cases. So we can see either by visualizing it in our head or by drawing it on our paper that statement 1 is not sufficient on its own. Now I'm ready to combine the statements, and since I've already done a fair bit of work for statement 1, I want to keep that work. I want to lean back onto that work because I've already done that work. So all I have to ask myself is, does statement 2 still allow for these possibilities that I was using for statement 1? Once I bring in statement 2, does that eliminate any of the options that I used for statement 1, or are they still viable options when I'm combining the statements? I already know statement 1 allows for these because I created them for statement 1. Does statement 2 eliminate any of them? I did not keep statement 2 in mind while drawing them. I got lucky. If you have a strong suspicion that it's going to be E, then it's a great idea to basically you're testing C versus E right off the bat if you have a strong suspicion that even when you combine these statements, it won't be sufficient. I mean, if you can show that the two statements combined are insufficient, you're done. There's no need to go back and try one of them on its own. I mean, if together they're not sufficient, then they have no chance of being sufficient on their own, because you're losing information and that's somehow giving you sufficiency. That wouldn't make sense. So yes, that's a good strategy when you have a strong intuition that the correct answer is going to be E, is to start by combining the statements. It's a little bit dangerous because often people make careless errors that way. They see that both statements together actually are sufficient after all, right? And then they just pick C. But they shouldn't. They should then try one on its own and two on its own. But if you're confident that you'll avoid that common mistake, then yes, it's a valid strategy to combine the statements right off the bat if your intuition is saying that the correct answer is probably going to be E. And then if you can show that together they're not sufficient, you're done. If we know that X and Y are on opposite sides of 0, then we can infer definitively that this left-hand side is greater than the right-hand side. That's what you're saying.
Yes.
Yes, That's correct. This statement is sufficient. Now, you should ask yourself, why is that the case? How come knowing this is sufficient to answer this, but knowing this is not sufficient to answer this? Why is that? Can you think of any other scenarios in which something is sufficient to answer a question, but not the other way around? Exactly. So one is a subset of the other. A numerical example would be the following. Is x greater than 10? Question mark. Statement 1 says x is greater than 5. Is that sufficient to answer the question? No. But the other way around, if we ask, is x greater than 5? And a statement says x is greater than 10, yeah, of course that's sufficient. Anything greater than 10 is greater than 5. So one is a subset of the other, and that's why, yes, this is sufficient to answer that, but not the other way around. Hey, I'm just going to interrupt my own video for a moment here. If you're finding value in this video, please let me know in the comments below. And give this video a thumbs up. It really motivates me to keep uploading a new video every day. Alright, back to the video. I just thought of an official GMAT question from one of the practice tests, which asks, are x and y both positive? And then statement 1 said x over y is greater than 1. And statement 2 said 2x minus 2y equals 1. So the question itself is very simple. It's just asking, are x and y both to the right of 0 in the number line? And it doesn't care what their relative order is, like which is bigger, x or y. It doesn't care about that. Just, are they both to the right of 0? And looking at these statements, I think I would probably argue that statement 2 is easier to evaluate, because statement 2 is just dealing with additive reasoning, whereas statement 1 is multiplicative reasoning. What statement 2 is implying is that 2x is to the right of 2y on the number line. In fact, we know exactly how far apart they are as well. The distance between them is 1, according to statement 2. And if you were to reduce that equation by a factor of 2, you could get rid of the 2 here and 2 here and say the distance between them is half a unit. They're half a unit apart from one another on the number line. X is to the right of y. That's what statement 2 is saying. And that's why you can do this. Exactly for that reason. Without knowing the position of 0, I can't even hope to answer the question. This is a bad habit that you have of assuming things about where 0 belongs when you really have no reason to assume anything about where 0 belongs. That's a habit that can cost you a lot of points on the GMAT. Celebrate the fact that you don't know where 0 belongs. Don't be like it sounds a little bit like you're maybe intimidated by not knowing where 0 belongs. Like it feels uncomfortable for you to not know where 0 goes. But you should flip that on its head. No, I love the fact that statement 2 gives no information about the positioning of 0, especially since the question stem is all about the positioning of 0. So if you have a question that's just interested in where 0 belongs on the number line, and a statement that gives no indication whatsoever of where 0 belongs in the number line, then it's a very easy elimination. So you have to get over this discomfort of not knowing where 0 is and change it into a good thing. I don't know where 0 is, and I want to make a big deal out of that. Yeah, I absolutely don't have any clue where 0 is here on this number line, and that's why I can eliminate B and D as answer choices. When they're talking about a difference between two unknowns, they're giving you the difference between the two unknowns. What you can do is place those unknowns on a number line relative to one another, and you'll know how far apart they are. You'll know which one is on the left and which one is on the right. You'll know all of those things. And that's it. That's all you know. You have no idea where 0 is because the statement wasn't giving you any indication about the position of 0. It's only giving you information about the relative order and the distance between the two unknowns. The GDP of the US grew by $150 million. I mean, this could happen in business school, right? In 3 years. And imagine that that's a statement. This is statement 1. And the question wanted to know, did the 3-year growth in GDP occur after the year 2000? Right? That would be analogous to are X and Y both positive? Right? Did this 3-year growth thing happen after the year 2000? And the statement tells you that the growth took 3 years. Yeah, this is a better analogy. The question stem doesn't tell us how many years it took for the GDP to grow by 150 million, right? Statement 1 does tell us that. But the question wants to know, did this growth happen after the year 2000? And statement 1 tells us how long the growth took to happen. This statement is not sufficient. This statement doesn't have any chance of being sufficient, just as this statement has no chance of being sufficient to answer this question, because this question is interested on which side of 0 they're on, and this just tells you how far apart they are. So we've evaluated statement 2, and we've established fairly quickly that it's not sufficient on its own. Now let's talk about statement 1. So statement 1 is giving us a ratio. And just to remind you all what a ratio represents, the way that I think about it, a ratio describes the number of times that the distance of the denominator from 0 fits into the distance of the numerator from 0. Like, how many times can I take that denominator's distance from 0 and fit it? If I were to copy it and then paste it over and over and over again from 0, how many times can I fit it in the distance of the numerator from 0? And if the ratio is positive, then they're both on the same sides of 0, and if the ratio is negative, they're on opposite sides of 0. So that's kind of a separate inference that we can take from a ratio. So one part of it is comparing the distances of the two numbers from 0, and the other part, the sign of the ratio, is describing whether they're on the same side of 0 or opposite sides of 0. And so what I would say here, so you were right, statement 1 is telling us that X and Y are both on the same side of 0. Why? Because their ratio is positive. And is that on its own sufficient, knowing that they're on the same side of 0? No, because we wanted to know which side of 0, right? Are they both to the right of 0? This on its own doesn't tell me that. But hang on, there's something else. There's another inference that we can make from statement 1. So far, all we've used is the sign of the ratio, the fact that it's positive. What else is statement 1 telling us? Well, the other thing, it's the number of times that the distance of y from 0 fits into the distance of x from 0. So if that number is greater than 1, what does that mean about the distances from 0? It means that x is farther away from 0 than y is. And what's another way to write that? So that's the second part, and the first part was saying that they're both on the same side of 0. So what's an algebraic way to state that? We could say their product is positive. They're both on the same side of 0. So here we have a plain English way of making inferences from statement 1, and we have the algebraic representation of that. Now, knowing both of those things, can we answer the question? Let's draw some number lines. Statement 1 says they're both on the same side of 0, and x is farther away from 0 than y is. So if they're both positive, then I know that the relative order looks like this, because I know that x has to be farther away from 0 than y is. And if it's the other way around, if they're both negative, still x has to be farther away from 0 than y is. So these are the two visualizations that statement 1 allows for. And that's why statement 1 is not sufficient on its own, and we can go ahead and eliminate A. Now to finish this off, I'll do something similar to what we did in the previous question, right? I'm going to say, look, I already know statement 1 allows for these two visualizations. Does bringing in the information from statement 2 eliminate one of those possibilities? It does, because statement 2 tells us that x is to the right of y, and if that's true, then this one is no longer possible. Statement 2 eliminates this possibility from statement 1, leaving us with only one possible visualization, which answers the question with a definite yes. Yes, they're both positive, because this is the only visualization left standing. If you found this video useful, go to quantreasoning.com for a lot more where that came from. You should also click that like button and let me know in the comments below what you'd like me to make future videos about. And of course, if you haven't yet subscribed, go ahead and do that and click that bell below so you get notified about future videos. See you next time.